Dear student, now we have to discuss question number 11. The question is, why are decomposition reactions called the opposite of combination reactions? Why these decomposition reactions are considered as the opposite of combination reactions? Write equations for these reactions. Dear student, here decompositions are considered as the opposite of combination reactions. Why? Because in a decomposition reaction, a single compound breaks down to produce two or more simpler substances. You know what happens in case of decomposition reaction? A single product, it breaks down into two or more products or simple substances. But in case of combination reactions, two or more reactants, they combine together to form a product. So that is why here decomposition is exactly opposite to that of combination reactions. For example, here in this equation, water, it actually breaks down into two simpler products of its own. One is hydrogen and another one is oxygen. So this is an example for decomposition reactions. So here what happens in case of decomposition reactions, these decomposition reactions involve breaking down a single compound into simpler substances, but whereas combination reactions involve combining simpler substances to form a more complex compound. So here what happens? A single compound breaks down into simpler substances, and whereas in case of combination, what happens? Two substance takes place and results in the formation of a more complex compound. Because of this reason, these decomposition reactions are considered as opposite of combination reactions. Dear student, the question is, write one equation each of the decomposition reactions. Write one equation each for the decomposition reactions where energy is supplied in the form of heat, light or electricity. The same question can also be occur in examination in a different form. Decomposition reactions require energy either in the form of heat or light or electricity for breaking down the reactants. Write one equation each for decomposition reactions where energy is supplied in the form of heat, light and electricity. Dear student, you know that in case of decomposition reactions, the single complex substance breaks down into simpler two substances. To break down into simpler two substances, the energy is required. The energy, either it may be in the form of heat, light, or electricity. So here we have to give the examples wherein the energy is consumed in the form of heat, light, and electricity. First one is calcium carbonate. So calcium carbonate, by absorbing the heat, it gives the simpler substances like calcium oxide and carbon dioxide. And in presence of light, by absorbing the light, silver bromide breaks up into its own simpler products, silver. And so in presence of electricity, that is known as the electrolysis of water. So here what happens? Water in presence of electricity breaks up into its own simpler substances like hydrogen and oxygen. So these are all examples for decomposition reaction in which the energy is absorbed either in the form of the heat, light and electricity. Question number 13. What is the difference between displacement and double displacement reaction? Dear student, here we have to differentiate between displacement reaction and double displacement reaction, and we must have to give the equations for both of these reactions. The displacement reaction is a reaction in which a more reactive metal displaces a less reactive metal. Here in this reaction, more reactive metal displaces a less reactive metal from its solution. This is what is known as displacement reaction. And what happens in case of double displacement reaction? In double displacement reaction, two reactants in solution exchange their ions. Here in double displacement reaction, exchange of ions takes place between two reactants. This is what is known as double displacement reaction. In a displacement reaction, more reactive metal displaces less reactive metals, whereas in case of double displacement reactions, in double displacement reactions, two reactants exchange their ions in solution. So this is the difference between displacement reaction and double displacement reaction. If we consider the examples here, the ion is a more reactive metal and copper sulfate is actually the less reactive. In this displacement reaction, copper is displaced by the ion and the reaction is like Fe ion reacts with CuSO4 aqueous solution and the products are copper and FeSO4. The highly reactive metal ion displaces copper here in this reaction. In case of double displacement reaction, what happens? Silver nitrate reacts with sodium chloride and exchange of ions takes place. We will get the products like silver chloride and sodium nitrate. This is double displacement reaction where silver nitrate and sodium chloride, both of these reactants exchange Cl ions and NO3 ions. So this is difference between displacement and double displacement reaction. Question number 14. In the refining of silver, the recovery of silver from silver nitrate solution involved displacement by copper metal. Write down the reaction involved. Dear student, here in the process of refining of silver, we will find recovery of silver from the compound silver nitrate solution. So by the displacement of the copper metal, what happens? We will recover the silver from the silver nitrate solution. So we have to write down this statement in the form of the equation. In this reaction, silver nitrate solution reacts with copper and gives us copper nitrate and silver. So here the silver is actually recovered. So this is an example for the given statement. Question number 15. Dear student, here the question is, what do you mean by precipitation reaction? Explain by giving examples. Let us understand what actually mean by the precipitation reaction with an example. Dear student, here the precipitation reaction is a reaction in which there is a insoluble solid which is known as precipitate that separates from the solution is called a precipitation reaction. Here what happens? Insoluble solid which is known as a precipitation which actually separated from the solution in this reaction. For example, when a solution of iron chloride FeCl3 and ammonium hydroxide are mixed together, so here the solution of both iron chloride and ammonium hydroxide when mixed together, here what happens? A brown precipitate of iron hydroxide is formed because in this reaction the precipitate is being separated from the solution.